Alright guys, so today in this lecture we'll try to understand operating system. It is known as the genie inside the computer. Okay, so if you look at computers, you might be like astonished to see that how does it works, how does it do all these tasks in a millisecond, and what is inside it. You must have that kind of curiosity in your mind, that what is it inside the computer. So that's what we call this operating system, which operates inside the computer, which make it possible for the computer to do such diverse kind of tasks in a fraction of second. So like, if let's say here, what like do you have left in your computer? Like, let's say you have a computer, you deleted all the other things. Okay, there is nothing left in your computer except for what is already installed in it. Let's say you delete all the things, all this stuff, then what is left in your computer is your operating system. Okay, so we will talk about this here in this lecture in detail about what is operating system. Okay, all right, in this chapter we will try to understand what is an operating system and how does it works. Where can the operating system be found before, during, and after computer has been turned on? What are some major interface difference in operating systems? Interface means the appearance of the operating system. For example, if you look at a Linux operating system, it's way different than Windows operating system. Okay, what are some memory constraints dealing with the amount of RAM memory and the size of the program to be stored there? And how does an operating system control information over a network? What do operating system have in common? Okay. All right. So it's time to formally define the operating system. So operating system is a collection of programs that manages and controls applications and other softwares and coordinates the various hardware components to perform tasks requested by the user. Okay, I think from the definition itself you got the idea that it is a collection of programs, different kind of programs, and written inside it that manage the programs itself and also control different application. Let's say there is a word processor, or there is a video player, like VLC or something. It manages all those application and all the software, so be it some utilities, be it some in other software. So it controls those softwares and coordinates the various hardware components. Different in computer, you can see that there are various hardware components. There is a network component. There is uh, there is a memory component. There is an input component, output component, and there are so many other things inside your computer. So it coordinates between these various components in order to perform different tasks requested by the user. Okay, so it allows the use of keyboards, mouse, printers if printer is attached to your computer, viewing information on your computer or monitor, saving or retrieving files, formatting a disk, running programs, controlling external device attached to the computer, and so many other things, like recording a video, um, or writing something. It controls so many other things. Okay, so like network card, it also manage the networking component. There are so many other things. So operating system manages all those things. In your CS program or SE program, you will study a whole, or subject, a whole, in a whole semester you will study this subject, operating system. It is in itself a very big, huge topic. Okay, there are lots of component, lot of very intricate concepts in operating system, which will you learn uh, in your higher semesters. So the first microcomputer, it was built in 1975, named as Altair 8800, and it had no operating system. It had no operating system. It was just you had to use different kind of switches. You have to turn on different switches uh, make it work, or merely to compute something. So next thing is BIOS. BIOS means basic input output system. So this is what we call as, it has small unchangeable part of operating systems in ROM. BIOS is basically stored inside ROM, uh, read only memory. Okay, it's an inbuilt memory inside your computers which cannot be removed, and BIOS, basic input output system, is stored inside the ROM. Okay. And what actually is BIOS? BIOS is a collection of programs that have capability of communicating with peripheral devices like keyboard, SSD card, disk drives, printer, display monitor, and other devices. Okay, and its most important task is to load the operating system into RAM and turn the control of the computer over to it. So now here's the thing: when you install a operating system into your computer, okay, you install a operating system into a computer. Where does it is stored? It is stored in your hard disk or your SSD. Okay, so now, how does your computer would know that when you just turn it on after a cold boot, like when you do a cold boot, how does your computer would know that there is some operating system in my hard disk and I have to pick that from there? That's where the BIOS comes in. Okay, the BIOS tells the computer that, okay, there is this operating system in the hard disk. I have to pick this up and I have to load into memory so that the computer start running. Okay, so that's how it works. Here, booting means just starting the computer. So whenever we boot the computer or start the computer invokes stripped down version of the operating system. It invokes the operating system found in the ROM, which I just talked about, makes the computer recognize the keyboard, floppy, and hard disk drive. So it make recognize all those parts of the computer, and then diagnostic are run on RAM and any cards residing in the computer, so that it would check all the RAM and all the cards are functioning, and then the program in ROM makes the computer look for the rest of the operating system on the floppy disk. So the next thing is the computer check the floppy disk, if the floppy disk or SSD check if the operating system is in there. If it can't find the floppy disk, it look for the rest of the operating system or hard disk or SSD. Okay, so it checks all those places, and if it finds the operating system, it load that into the RAM. Otherwise, it shows some error if there isn't any. Okay, the operating system found on our floppy or hard disk drive SSD is loaded into a RAM, and the program residing in RAM now controls the computer. So that's how it works. Now there's two type of boots: cold boot or warm boot. Cold boot means you are just starting your computer after shutdown. Okay, after shutting down your computer, you are starting it up. Or if your computer is totally off, totally turned off, and you're turning it on, that means cold boot. In such cases, the operating system in ROM, okay, so the BIOS in ROM looks for and load the remaining operating system into RAM. So that's how cold boot works. While in warm boot, the The computer reloads the operating system into RAM without disrupting the power of to the disk drives or power supply. So that's how it works. Let's say you hibernate, that's a warm boot, or you refresh something, that's also a warm boot, and this are sort of things. All right, so there's also an option where you can boot your computer with multiple operating systems. You could boot your computer with Linux and Windows at the same time. So that's also possible. If you haven't done that yet, I would recommend that for practical purpose you should just check it out. That um, how you can boot Windows and Linux operating system at the same time, and you can switch between those and work on those as per your need. So it's common when you need to run program recognized by all the operating systems, and for example MS-DOS and Windows, and we you booting with multi is also common in Linux and Windows. And here we do partitioning in the disk, where we divide the hard drive or SD, so that it appears to the computer to be two or more separate disks. So what happens is, whenever our computer is, we double boot any computer with multiple operating systems, like Linux and Windows, we need to allocate different, separate disk drives for both of them, so that they could load um, the so that they could load the operating systems from that disk drive into the RAM and operate as accordingly. So that's why we need to partition the hard drive. Then user interface. If we talk about user interface, there are the user interface varies from operating system to operating system, as well as there are two type of interfaces. One is command line and other is graphical user interface. Okay, so the part of yeah, so if we define a user interface, it is the part of operating system that user sees and communicate with. Like whatever you see in your computer when you turn it off and you see the UI, you see the application icons and all these things. That is a GUI, graphical user interface. That's as user interface. And if you're someone who used coding and also are like running something from command line or CMD, if that what suits you best, then that's also a interface and it's called as command line. So basically it is a way to communicate with the computer. So yeah, for example, like command line, you can, if you are creating some directories, then you can use mkdir or xyz, or you can use touch to create files, and so many other things like that. And you can also use a graphical interface, which is very beginner friendly, or you can say people who are not a technical background, it suits them very fast. They don't need to understand the command line, don't need to understand the commands. They just can create or delete or some or operate or communicate with the computer using the GUI, which is very, interesting, as well as very easy to use. Now, version number, every operating system and every applications comes with a version number, because whenever you create something, you create a version number in order to identify that in the future, if you improve uh, the quality of the computer, or you add something new features or something like that, it would not conflict with the previous one. Let's say you created something in your previous version, it was something else, in the next version it is something else. So uh, in order to just avoid the conflict, we use version numbers, and it indicates the versions or variants of the program being considered, and release and modification number give every more specific information about the program variants. And why it's important to know version number? Because programs such as word processor, spreadsheet, and others are written for particular version of the operating system, so they may not be compatible with each other. They may not be compatible with the other versions. So that for therefore uh, we need to know about the version numbers of every computer. That's why we need to learn. We need to understand the version number. Unix has different operating system. Unix are used. It's mostly used by professional and high-power computers, and it is mostly used by people who know that tech very much, and not people who don't really understand how it really works. So it's mostly used by tech-savvy people, and it's open source software, so the original program is available. Changes can be made to suit computing needs. You can also change the operating system by your own and use it for yourself. So it is the most uh, famous version of it is Linux, and Kali Linux is also there. So these are some version of the Unix which we use nowadays. All right, so file, it's the name given to any program or chunk of data that is stored on floppy, hard disk, CD-ROM, or other storage devices. I think there isn't any need to define it because you already know what is actually is file. But if we talk in computer science perspective, it is just a name given to a chunk of data. Okay, chunk of data, and it's a particular extension is used. Let's say if you are storing image, then you would use either PNG, JPG, or JPEG, whatever. If you're using want to store things in PDF format, that then you would use dot PDF, and if it's text format, then dot TXT. And there are so many other extensions which you use. So it's a three-letter extension separated by dot is used, and so the purpose behind using the extension is that it helps the operating system identify the type of the file and treat that accordingly. For example, index.html identifies a document called index that is made up of HTML code, or as I just mentioned, the .pdf. It represents a PDF non-editable document file, or if CSS extension is docx, then it would be doc file documents, which is editable. So, or if it is XLS, which is used for Excel sheets. So that sort of extensions we use with each file for the computer to understand what actually in the computer and how to treat it. So there are two type of file system. One is flat, which just stores things in just list format, single list. So that's one format. But there's also a hierarchical format. Nowadays, in every computer, you would use it. It uses a hierarchical format, where in each folder you would get different folders, and in folders you would get different files. So it uses a tree-like structure or hierarchy to store things, and it organizes files into groupings. So folders are basically the groupings of files or other folders under a single name. So that's what we call as folder. Yeah. So inside folders, there could be files, there could be many folders, as much as you want. So what makes binary information of this type different to the computer? What makes the difference? Like number, text, or characters, visual information, audio. So now the computer has no way of understanding or knowing which five type of information is in the file, unless um, a person, or unless you explicitly tell the computer that this is visual. Like, let's say if it's an image, then you would use PNG, JPEG, or GPNG or whatever. So you would use that extension, so the computer would know that, oh, this is a visual, something to do with visuals. Or if that's audio, then you would use MP3. So the computer would understand that, okay, this is something with audio, so I need to treat it with audio, like as a audio. So that's how it understands whether to which category does the computer belongs to. Now, a compatibility problem, it arises. It's I think it's just going out of the way just to describe the compatibility problem, but the compatibility problem is actually it occurs when there are different versions of thing, and when let's say your operating system wants version 3 of any source code or any file, but you have version 2. So that arises a compatibility problem. Okay, so files created by the same type of program are not always interchangeable. um, Example could be, we cannot always interchange file created by one word processor to another. And let's say, I'll give you an example of it. Let's say if you create a file in Linux, Libre. Okay, Libre is a word processor in Linux. If you create a file, a document file in Linux, and you use in Windows, you won't be able to use it in Windows because the extension is different. They are the same kind of things, or whether you have written some kind of things at it or not, but you won't be able to open it in in window without any third-party softwares. So that's why that's what the compatibility problems means. Now, installing new device. In order to install a new device, we need a physical connection with the device, peripheral device, and we also need a proper software driver, which must be added to the operating system, collection of programs. And what device driver do is, let's say you want to install something into your computer using the USB. Okay, so to understand what is in the USB, your computer needs some kind of driver, which would first make sense of the stuff inside the USB drive and then communicate it with your computer. Okay, so that's why we need drivers. For example, for your microphone, there is a driver. For your speaker, there is a driver. For your network, there is a driver. Network driver. For your Bluetooth, there is a driver. So for everything to make sense to the computer, we need a driver, and these are program that will allow communication between operating system and other part of the computer, usually peripheral devices like printer or scanner or networking cables or so many other things. And it is just you can say that it's in addition to operating system. Now, VRAM or video RAM, so it's very fast RAM. If you look at the videos, it's nothing but images playing in a particular order in a particular time frame. Okay, so they usually change very fast. Images change very fast, so we see them as video. Okay, in order to run those things, the general RAM does not really give a good experience because it is not that much fast to process the video frames or the image frames which are being played in a particular time frame as a video. So for that, we need something very fast and quick. That's where the VRAM comes in. It's video RAM. It's very fast memory. It's used by operating system to house video display data that allows quicker, better video display. And as I just mentioned, RAM isn't fast enough to make quick changes to in the display. So by putting the image data into this faster video RAM, the delay can be minimal. Okay, so then virtual memory. Now, sometimes what happens is when we store so many things into the let's say when we have so many things in our computer, let's say we are running so many um, softwares in our computer, sometimes it runs out of memory. Okay, sometimes it run out of memory, or it run out of its RAM. And when the RAM becomes full, or your processor consumes your RAM fully, then it slows down. It starts slowing down because there isn't any space for upcoming um, data, okay, from the hard disk. Therefore, virtual memory is used. Okay, so what is the function of virtual memory and what is virtual memory? Virtual memory is from the name itself, you could get the idea. It's virtual, or just virtual memory. It's not the actual memory. It's virtually. What happens is whenever there's no space in your RAM, the computer, not the computer, but there is virtual memory which has been designated inside the hard disk, inside your disk. We just treat it as RAM. Okay, so here is it's saying that it addresses the problem of our program being too big to fit into the available RAM. So the operating system divides the program into pieces. Okay, the pieces are stored on the hard disk as if it were additional RAM memory needed by the program, and the pieces are retrieved into memory as needed. And the disadvantages is that they slow the system down because retrieval of information from disk is time consuming. Okay, so again there is uh, it also slow down the computer. But let's say you are running a very huge software. Okay, so that software do not fit into your RAM. You have just 2 GB RAM or 4 GB, 8 GB, whatever. If your software is more than 4 GB, then that would not fit into your RAM. Therefore, we need some kind of virtual memory where we could store our files, data. We store the program data or files or code, and we could fetch that into the RAM as per the computer CPU needed. Okay, so that's how the virtual memory works. It's basically used to address the problem of programs which do not fit into the RAM, which are too big and do not fit to the RAM. So that's why we use it. And then context switching and multitasking, it's a very broad like very important concept to understand context switching and multitasking. How your computers uh, how your computers are able to do multiple tasks. You have different tabs open in your computer. You're doing so many things in a single computer. How is that made possible? Or in your mobile phone, if you look at your mobile phone, you could have open different applications. You're running the, and how is that possible? Now, that's again a very important question to ask yourself, that how that is made possible. Okay, so context switching means just switching from one context to another context, and it from one here the context means from one application. For just simplicity, you could take an example that it is switching from one application to another application. Let's say you have too many tabs open in your computer and you switch from one to other. That's a simple definition of context switching. You're switching from one to another. In a similar way, the computer do the same inside. It allows several applications programmed to be in the RAM at one time, and it allows switching from one program to another, such as from word processor to spreadsheet and back again. Both reside in the RAM. And the limitation to this is that the only active program is the one just switched to the other or inactive. So the limitation that those programs becomes active which are being used, and those which aren't being used will not be active. So that's the downside of it. Now, multitasking, it allows several applications program to be running at the same time, and it allows the operating system to control more than one program simultaneously, and each program is stealing CPU time. Obviously, if something is running in your computer, then that must steal the CPU time, that must consume the CPU time, such as playing a video game while documents being printed. So that's, yeah, a kind of multitasking. And now, in one human architecture, there is a bottleneck. There is a downside to it, is that microcomputers have only one program counter, can run only one program at a time. Okay, so the CPU can only process single instruction at any one time, no matter how many tasks there are. So there is a downside to it, that you're doing multitasking, you're switching from different things. But if you look at the architecture, that the architecture in itself, that your CPU just execute one instruction at a time. Okay, no matter how many multitasking you're doing, your CPU always do one instruction at a time, do one thing at a time. So that's just bottleneck to it. But we are using nowadays, we use multiprocessors, so that is being reduced to a certain extent. There are two categories of operating systems. Operating system with single CPU. I don't think that nowadays there is a single CPU operating system nowadays. All are multiprocessor. And the multiprocessor system that has many CPUs, such as the computers we have, the mobile phones we have nowadays, they are all multiprocessor. Okay, they are at least some are quad core, some are dual core. So yeah, and parallel processing or multiprocessing, it is a kind of processing where we divide your program into different pieces, and you give each processor. Let's say you have four processors in your computer, and you are giving each set of programs to different processors. Okay, so that's what parallel processing and multiprocessing means. Then there also is a distributing processing, in which we use networking, and we assign tasks to different computers, and at the end, the computers communicate with each other to perform particular tasks. So that's also an option if you have something which is very huge, you're doing something very huge, and that could be, let's say, for example, you're playing a PUBG. Okay, that's a very famous one. Let's say you're playing PUBG. That's also an example of distributed processing, where each computer in a separate place, they are communicating via a network, and they are doing different tasks, but in but are interconnected with each other. Let's say you are playing PUBG with a friend, you're killing uh, the army, the players of that person, and he is killing your his opponents. Okay, so you are doing different processing in your computer, and your friend is doing uh, something in his computer. So you are communicating in a decentralized way. This type of processing is called distributed processing. Okay, and operating systems designed for network handle all that single computer cores and chores, and communicate with all the computer in a network. One computer's on another network shared. You need storage. Server is a computer that provide data and program on request from multiple friends. So server and client. That's again a very interesting topic which you need to understand. It's mostly used when it comes to web development, and in a world of internet, especially web development, where one part is called a server and the other is client. Let's say when you request something, when you click on some web pages on the internet, on Google, then the data in that application are served to you through the server, which is in the backend, which you don't see, but it gives you all the things, all the HTML, CSS, JavaScript, whatever to you. That is what we call the server. Real-time processing uh, means communicating with the computer in a real time, like ADM, where a customer wants cash, so that's a real-time processing. Then process control, it refers to control of some processes by computer in real time. So a computer needs to accept information, then manage the process on the basis of calculation. For example, maneuvering a robotic arm, automobiles, computerized traffic signals at intersection, control traffic flow. So yeah, it's process control. So some cutting edge operating systems. We have three most famous, I think, operating systems uh, for computers, especially the laptops and all this, which are Windows, Mac, and Linux, and uh, and there's also Android, which is being used in mobile phones. So yeah, that was some cutting edge operating systems. And running applications. So running application on computers. Um, Before we purchase any computer, we need to examine that what is inside it. It's obvious that whenever you buy something, you uh, try to understand all the specs. Are you buy something based on all the specifications, right? What RAM inside it, what is the processor, what version of operating system, version or operating system doesn't really matters, but the whole architecture, the processes, and all those things does really matter when you are buying something, purchasing some software. Okay, so in purchasing software, yeah, you need to understand that in our country, we don't really purchase any software because I don't know, we take everything for granted, and we you just don't buy any softwares. If anyone of you have ever uh, went to went to shops do a boot to boot your computer with the Windows operating system, or to do uh, yeah, to install the Windows operating systems in your computer, then you must be charged with something. That's one thing. But before installing all those things, you need to understand that what operating system is being installed into your computer, be it Windows 10, Windows 11, or whatever. So yeah, that's where you need to understand the purchase, understand the version of computer before purchasing it, and also all the specs of it. Access to previously stored information. Operating system assists in creating new documents. So it operating system, it access it helps you create a document. It helps you manipulate different documents. It helps you do different tasks. So it is the function of the operating system or in general any computer to help you with doing stuffs which you expect from the computer. And controlling and communicating with peripheral devices, that's one aspect of it where you need to control also the operating system. You need to control and also communicate with the different device like the printer, the mouse, and so many other things. So you need to communicate with that. And in modern computers, we have just plug and play. Whatever you just need to plug in into your computer and just use it. So that's how we like. Let's say you want to uh, you want to plug a keyboard with your computer and want to use that. You just plug in the cable of the keyboard and use that. And connecting computer to your network. So in order to connect the computer to your network, also you need to have a connecting device which you could use to connect computer into your network. That's also, and computers connected to network need to be able to share files, They could share files via computers, and operating system must be configured to network specification. Yeah, that's also a very important thing. And then we have for manage and add compatibility. It's just all operating systems are built to be extended by adding software to the operating system. New features that can be added. So that's just, I think, obvious things. We don't need to emphasize too much on this. Uh, and why we use operating systems and what is fragmented disk. Fragmented disk is basically you divide the disk into different fragments. Like we have A, B, C, or D different fragments in your computer. If you're using Windows, just click on this PC and you would see that there are disk C, disk E, disk F, whatever. So you could fragment that, and you could also defragment um, your computer by just deleting all those fragments and just merging it into one. That also works. All right, so that's all for this lecture. See you in the next one. Till then, keep learning and keep improving. Thank you very much.